Hi, this is Dave Johnson. Welcome to another edition of Math Off Topics. Today, I want to show you how to find one limit from another. And you're studying limits now in your calculus course. Probably you're seeing lots of different kinds of limits. And there's many different ways of showing that a limit exists, finding the value of a limit, um, and talking about right hand limits, left hand limits, and so on. But one thing that you might not realize is that you can take an existing limit and show that and derive another limit from that. Now, it doesn't happen very often, but when it does, it's a very powerful technique. And so I want to show you an example today. This is hopefully going to be a short, quick video. Let's get to it. So uh, we want to show that the limit as p goes to 0 of e to the p minus 1 divided by p is equal to 1. And your textbook probably shows you that this is true. I'm going to show you a way to do this in a very intuitive procedure, which you can use on other kinds of limits. We're just going to do this one today. But so, where do we start from? We're supposed to show that this limit exists. And by the way, this is really easy to do with L'Hopital's rule. But if this is early in your calculus course, you may not be allowed to use L'Hopital's rule. Why? Well, because you don't know how to do a derivative yet. Even those of you who may have seen the derivative before and may know what L'Hopital's rule is, your instructor may say, no, 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 let's not use L'Hopital at this point. Let's try some other way of doing it. So we're going to start with an existing limit that we have already seen, hopefully by this point, the definition of E. So E is equal to the limit, and we're going to use P here. P approaches 0 of 1 plus P raised to the 1 over P. Another way to do this would be to say that, say, limit as x goes to infinity of 1 plus 1 over x raised to the x. But it's going to be easier in this case to use the limit where p goes to 0. So now what's the idea behind this method? Well, we're going to say that e is approximately equal to 1 plus p raised to the 1 over p when p is small. Now, when I say small, you might ask, well, how small is small? Well, it's only really true when e is or when p is very, very small. In fact, the limit is p goes to 0. Yes, but uh, there's nothing in this equation that says that p can't be small. Maybe zero point zero 0.01 or something like that. And we're not going to specify exactly what the value of p is. We're just going to say that it's small. And in fact, we're going to behave like p is small, and we're going to treat this as an equation. So let me go ahead and write E is equal to 1 plus P raised to the 1 over P. And again, I'll say when P is small. And so each step of the way, we need to ensure that P is small. And not only that, it makes sense as an equation if P is small. Now, if P is 0, then all bets are off. But let's think about this for a moment. This when we say that P is approaching 0, it is never the case that p is going to actually reach 0. In fact, that's the idea of a limit. It's the behavior of a function as p gets closer to 0 in this case, doesn't actually go to 0. So, okay, well, if that's the case, then let's raise both sides to the p power. So e to the p is equal to 1 plus p raised to the 1 over p, and then that whole thing raised to the p power. And you know what you do with those exponents. P times 1 over p is 1. So we can rewrite this as e to the p is equal to 1 plus p raised to the 1, but 1 plus p raised to the 1 is just 1 plus p. Okay, Now we're going to subtract 1 from both sides. So we get e to the p minus 1. And I know I need to do this because I see an e to the p minus 1 up here. I don't have to memorize the derivation. I can use algebra and I can look at the goal, the end state that we're trying to get to guide the algebra. So I'm going to subtract 1 from both sides. That leaves p on the right side. And now we're going to divide both sides by p. And of course, in both of these cases, we can only do that as long as p is small. So I'm using the ditto marks here when p is small, when p is small. And then now I'm going to divide both sides by p. So e to the p minus 1 divided by p is equal to 1. But that's only true when p is small. But now we can rewrite that as a limit because p is small in this case means that we're going to take the limit as p goes to 0 because we know really that's what it meant from the beginning. P has to be very tiny, but not 0. So I can rewrite this as limit as p goes to 0 of e to the p minus 1 divide by p, and we know that that's equal to 1. And I can box that answer, and we know it's true because of the way we've derived it. And that's exactly what we were trying to show. So, perfectly legitimate way to do the derivation, and the result is valid. So, hope you have enjoyed this video. If it's been helpful, subscribe to my page. And if you think it's worth it, give it a like, and I'll see you next time.